Turtles are among the oldest reptiles on Earth, with a fossil record stretching back more than 200 million years, outliving dinosaurs and countless other species. A huge part of their incredible longevity and resilience lies in their ability to survive extended periods without food, a trait that is not a random accident, but a masterpiece of evolutionary engineering, fine-tuned by millions of years of adapting to Earth's most unforgiving environments. From the tiny box turtles that take shelter in North American woodlands, to the giant Galapagos tortoises that dominate tropical highlands, from freshwater turtles that thrive in quiet ponds and rivers, to the massive sea turtles that cross entire ocean basins, every single turtle species shares this life-saving superpower. This ability to fast for long stretches is not just a party trick of nature. It is a core part of their biology, allowing them to survive droughts, cold winters, food shortages, and long migrations where meals are hard to find. In this documentary, we will dissect every layer of this amazing adaptation, exploring their uniquely slow metabolism, specialized energy storage systems, the game-changing behaviors of brumation and estivation, the vital role of their iconic shells in conserving energy, and their hyper-efficient digestive systems that turn every morsel of food into lasting fuel. By the end of this story, you will never look at a turtle the same way again. You will see them as one of nature's most resilient, well-adapted survivors, built to endure when other animals would perish. To understand why turtles can go so long without food, we must start with the most fundamental part of their biology. They are ectothermic, or cold-blooded animals. Unlike humans and other mammals, which are endothermic and must burn constant energy to maintain a steady body temperature, turtles rely on their surrounding environment to regulate their body heat. This single difference is the foundation of their ability to survive without food for months. Mammals spend up to 90% of their energy just keeping their bodies warm, even when they are resting. A human, for example, needs to eat regularly to fuel this constant internal heating, and we would struggle to survive more than a few weeks without food. Turtles, however, have no need to waste energy on internal temperature control. When the sun is out, they bask on rocks or logs to warm up, speeding up their bodily functions slightly. When temperatures drop, their body processes slow down dramatically, and their energy use plummets. A turtle resting metabolic rate is just 10% to 20% of that of a similarly sized mammal. This means they use energy at a glacial pace even when they are active. They move slowly, breathe slowly, and their hearts beat at a fraction of the speed of warm-blooded animals. A resting turtle's heart may beat only 5 to 10 times per minute, compared to 60 to 100 beats per minute for a human. This ultra-slow metabolism is the first key reason they can survive without food. They simply do not need much energy to stay alive. Every calorie they consume is used with extreme efficiency, not wasted on keeping warm or fast movement. The second critical piece of the puzzle is how turtles store energy for long fasts. Before food becomes scarce, whether before winter, a drought, or a long migration, turtles go through a period of intense feeding, gorging on plants, insects, small fish, or algae, to build up massive energy reserves. Their bodies are expert at storing excess energy in two main forms, fat and glycogen. Fat is stored in specialized tissues throughout their bodies, including around their organs, under their skin, and even in their tails and limbs. Glycogen, a quick-release form of energy, is stored in their liver and muscles. These reserves act like a built-in battery, slowly releasing energy to keep their cells functioning, their organs working, and their bodies healthy during periods when no food is available. Unlike many animals that burn through energy stores quickly, turtles break down fat and glycogen at an extremely slow rate, matching their slow metabolism. A large Galapagos tortoise, for instance, can build up enough fat reserves in a few months of heavy feeding to survive an entire year without eating. Even smaller turtle species, like box turtles, can store enough energy to last through 3 to 4 months of winter brumation with no food at all. This efficient energy storage system means turtles never face sudden energy crashes. They have a steady, reliable supply of fuel to carry them through lean times. Next, we must explore the two life-saving behaviors that let turtles survive even longer without food: brumation and estivation. Brumation is the reptile version of hibernation, and it is a state of deep dormancy that turtles enter when temperatures drop in winter. During brumation, turtles bury themselves in mud at the bottom of ponds, under leaf litter, or in soft soil, where temperatures stay stable and above freezing. In this state, their metabolism drops to an almost imperceptible level. Their breathing slows to just a few breaths per hour, and some aquatic turtles can even absorb oxygen through their skin, eliminating the need to surface for air. Their heart rate slows to just 1 to 2 beats per minute, and all non-essential bodily functions like growth, reproduction, and movement shut down completely. The turtle's body focuses only on keeping vital organs alive, using almost no energy in the process. A box turtle in Brumation can survive 4 to 6 months without food or water, relying entirely on its stored energy reserves. Estivation, on the other hand, is a similar dormant state that turtles in hot, arid regions use to survive extreme droughts and heat. Desert tortoises, for example, dig deep burrows underground, where it is cool and moist, and enter estivation during the hottest, driest months of the year. In this state, they conserve water and energy, slowing their metabolism to avoid overheating and starvation. Estivation can last for months, allowing desert turtles to wait out the dry season until rain returns and food grows again. These two behaviors are not just sleep, they are advanced survival strategies that turn turtles into energy-saving machines, letting them stretch their energy reserves for months on end. Another, often overlooked factor in a turtle's ability to go without food is its iconic shell. The turtle's hard, protective shell is more than just a shield against predators. It is a critical tool for energy conservation. The shell is made of bone and keratin, and it provides complete protection for the turtle's soft, vulnerable body. This means turtles do not need to waste energy on constant movement to escape danger. Instead, they can pull their head, legs, and tail inside their shell and stay completely still for hours or days at a time, using almost no energy. Other small animals must stay alert and move constantly to avoid being hunted, burning precious energy in the process. Turtles, however, can remain motionless for long periods, safe inside their shells, preserving every calorie for survival. The shell also reduces water loss, which is closely linked to energy use. When an animal loses too much water, its body must work harder to maintain balance, burning more energy. The turtle's shell locks in moisture, so they do not need to drink often, and they do not waste energy regulating water balance. This combination of protection and energy conservation makes the shell an essential part of their fasting ability. Finally, turtles have a hyper-efficient digestive system that maximizes every nutrient they eat, so they need to eat far less often than other animals. Most animals digest food quickly, passing it through their bodies before absorbing all the nutrients. Turtles, however, have a long, slow digestive process that can take days or even weeks to complete. Food sits in their digestive tract for a long time, allowing their bodies to break down and absorb every single vitamin, mineral, and calorie from their meals. They extract more nutrition from a small amount of food than most animals can get from a large feast. This means that when they do eat, they get the absolute most out of every bite, reducing the frequency with which they need to feed. Their digestive system also adapts during fasting. It slows down almost completely, so no energy is wasted on processing food, and the body focuses solely on using stored energy. This digestive efficiency, paired with their slow metabolism, makes every meal count for weeks or months. When we put all these pieces together, their cold-blooded metabolism, efficient energy storage, brumation and estivation protective shell, and super-efficient digestion, we see why turtles are unrivaled in their ability to survive without food. This is not just a random trait. It is the result of 200 million years of evolution, shaping turtles to thrive in environments where food is unpredictable. They have survived ice ages, droughts, mass extinctions, and changing climates because their bodies are built to endure. Turtles are a living testament to the power of slow, steady adaptation, and their ability to fast for months is one of the most amazing wonders of the natural world. Whether you spot a turtle in a local pond, a pet store, or a far-off desert, take a moment to appreciate the evolutionary marvel that it is a creature that can outwait hunger, outlast harsh conditions, and survive when so many others cannot. Please like, comment, share, and subscribe to the channel.